Hello, grade 4. How are you today? I hope you're fine. I'm also fine. I hope you're washing your hands and wearing your mask as well. So I'm happy to be with you here again. And today we talk about magnets. So welcome to science time. Okay, so last week we talked about magnets. Yeah, and we say that a magnet, we have two types of magnets. This one is a horseshoe magnet, and this one is a bar magnet. Okay, so these magnets, they have a magnetic force. Okay, they can attract what? Things that are made from metal. Yeah, but they cannot attract some things that are made from rubber. So to do this experiment, we are going to turn to our books, our activity book, on page 25. Okay, we are going to start on page 25. So let's continue. Now, measuring forces, page 25 of your activity book. Now, let's see what happened when we want to measure force. Now, we can measure force using what? A spring balance. Remember, last time when I was talking about force, I talked about spring balance. So we use a spring balance to measure force. Now, and what is the unit of force? The unit of force is Newton. Newton is the unit of force. Now, this is just a review on what we did last time. So, we measure force or a pulling force by using a what? A spring balance. And this is how my spring balance look like. Can you see my spring balance? So, this one here, we use it for measuring force. Now, a spring balance has grams and newtons. Grams and newton. It means that this side we measure grams and this side we measure the newtons. So, what happened? The greater the reading, the greater the amount of force applied. If we have a spring balance and it goes down, like it pulls this down, it means that the object has greater mass. Okay? So, it means that it has a greater force. So, let's continue. Let's look at our next tip on page 26, number 3. Page 26, number 3. So, here we are going to measure some things. I have a bag of stationaries. I have some pencils, I have some erasers and stuff. And here I also have what? A bottle of water. So we are going to measure the Newton or the force that is exerted by these two objects. So I'm going to start with a small bag with something inside. Now, so let's see how many newtons or how many grams. Okay, so you see this one here. When I put this, it shows me it is 1 Newton. 1 Newton. So that is what? 1 Newton. So bag with small objects is 1 Newton. Now, next, let's see this water bottle. What is the weight of the water bottle? Okay, so this one here, it exerts what? I can read this. I think you cannot see that, but it is 3 newtons. 3 newtons. So that is around 300 grams. Okay. So you see here that bag with small objects is 1 newton. Water bottle is 3 newtons. So which one has exerted a greater force? Is it the bag or the water bottle? Which one has a greater force? So let's look at our next page. The questions we have: which exerts a great force on the spring balance? The bag or the water bottle? Which one is heavy? the bag with stationaries or the water bottle. So you write the answer there. Then number 2 says, what is the unit of measuring force? Like I said before, the unit for measuring force is Newton. Very good. Now, in your conclusion, you will fill in the blanks with the word greater or the spring balance. So, here we have these spaces. You need to fill them up with greater or spring balance. So, a dash can be used to measure pulling force. The greater the reading on the spring balance, the dash is the force applied. So, what is the answer? You have to use these two words here, greater and spring balance, to fill in the conclusion box. Okay? Next, page 27, we are going to talk about magnetic force. The magnetic force, this one here, okay, and how it is exerted on objects. So, for this one here, our conclusion will be, if the magnet is far from the object, there will be less attraction. If the magnet is near, there will be more force of attraction. Now, this one is all about the distance. If the magnet is far away, there will be less attraction. But if it is near, there will be what? More force of attraction. Good. So, we are going to do an experiment about this, and I need you to turn with me to page 28. Okay. We are going to check on the distance between the bar magnet and the steel paper clips in centimeters. Then, you will write your observation, attracted by magnet or not attracted by magnet. So, here we have a tripod and we have a bar magnet. We are going to check if it can be attracted by magnet. So, if it is shorter, if it's not near, let's see how many centimeters. This is 12 centimeters. So, the first one is 12 centimeters. Now, is it attracted to the magnet? No, it's not attracted to the magnet. Now, let's increase the string and see if it will be attracted. The next one is 17 centimeters. Is it attracted by magnet? No, it's not attracted by magnet. So, and let's see the last one. Whoa! So it is attracted. Now, this is 22 centimeters. So you can see from 22 centimeters, it is attracted by the, or they are attracted by the magnet. So, if it is far away from the object, it cannot be attracted, okay? This one, not attracted, but the 22, because it's near, it is attracted by the magnet. Okay, so our question is, when the distance between the bar magnet and the paper clip is very small, like this one here, you see, if the distance is small, yeah, then it can be attracted. It is attracted by the magnet. But if the distance is large, can it be attracted? No. So if it is large, it cannot be attracted. But if it is small, it can be attracted. So for this one, I need you to circle the correct answer. You can either circle can or cannot, or can and cannot. Read the question first before you circle the answer. So next, let's look at the conclusion. Okay, so what is the conclusion? What can you conclude from this experiment? It's that if the magnet is far, if the magnet is far away, then it cannot be attracted by a magnet. But if it is near the magnet, it is attracted, okay? When it's near, it is attracted, but when it's far from the magnet, it cannot be attracted. So that is your conclusion. it means that if an object is far, it cannot be attracted. But if it's near, it can be attracted by the magnet. Good. So, now, look at page 29 of your activity book. We are going to do a magnetic check. So, what is this? A bar magnet. What is that? Rubber band, thumbtack, marble, nail, and handkerchief. Okay. And what else do we have? We have ruler, paper, and aluminium. So all of these things I have them here. These are marbles. This is nail, rubber bands, thumbtack, aluminium, ruler, and what? Paper. And I also have what? Bar magnet. This is my bar magnet. So we are going to see, and this is handkerchief. Handkerchief. You can use it to wipe your face, something like that. So we want to check if these things can be attracted by magnets. Okay? So in the observation column, let me see. In the observation column here, you're going to place a tick if it's attracted, and a tick if it is attracted, and cross out if it is not attracted. Attracted, you put a tick. Not attracted, you put a cross. So, for your own prediction, I want you to tell me, like, if you have rubber band, can it be attracted by a magnet? Okay, so this one here, you write your own prediction. Prediction is what you think before we do an experiment. Okay, so first of all, we are going to check what is a rubber band made from. So materials that these things are made from. A rubber band is made from rubber. Good. And a marble, Chokun, what is a marble made from? This one here. A marble is made from glass. Very good. And what about a thumbtack? Diamond, what is a thumbtack made from? It's made from metal. Good. Okay. And ozone. Our next is a nail. This one here. The nail. The nail is made from metal. Good. Next we have handkerchief. This one here. What is it made from? It's made from cotton. Okay. This is made from cotton. Then we have what? A ruler. What is this made from? Aha. The ruler is made from plastic. Yeah, it's made from plastic. Then we have a paper. What is it made from? It's made from wood. Wonderful. And lastly, we have what? Is this? Aluminium foil. So what is it made from? It's made from aluminium. So we are going to check, okay? We do it one by one and see if it is attracted or not. So what I'm going to do, I'm just going to check if it is attracted, and you will see, and then you put a tick or you cross. So the first one we start with rubber band. See, this is a rubber band and I have what? I have a magnet. So let's see. Is it attracted? No, it cannot be attracted by magnet. So what do you put here? You put a tick or you cross. Remember, I say that if it can be attracted, then you put a tick. But if it cannot be attracted, you put an X. So the first one is rubber band. Is it attracted? No, it's not attracted. Next we have marble. Remember, the marble is made from glass. So I'm going to try the marble. Is it attracted? No, it's not attracted. Okay. Next we have thumbtack. Now, this is made from metal. I'm going to show you. Okay. Can it be attracted? Aha, you see? It is attracted by magnet. Next, we have the nail, tapu. Yeah. This one here, I want to see if it can be attracted. See, it is attracted. Yeah. Good. Our next one is handkerchief. This is made from cotton. Okay. So let's see. Is it attracted? No. No, it's not attracted. Okay. Ruler, which is made from plastic. Some rulers are made from metal, but this is made from plastic. This is what we have. Let's see. Is it attracted? No, it's not attracted. Okay. Next we have paper. Let's see if it's attracted. Sorry, it's not attracted. Okay. And the last one is aluminium. Let's see. Is it attracted? No. Aluminium is not attracted. So, let's see what we have found out. Rubber band is not attracted. Marble, not attracted. Thumbtack, it is attracted because it's made from metal. Nail is attracted. Handkerchief, no. Ruler, no. Paper, no. Aluminium, no. So, we find that things that are made from metal can be attracted to a magnet, but things that are not made from metal cannot be attracted by magnets. Okay, so our next page, look at page 30. Okay, that is what we did, and now this is the conclusion. Okay, so what I need you to do, I need you to fill in the blank spaces. Okay. These are here. So some materials are attracted by magnet, like we did. The thumbtack and the nail are attracted. So while others are not. So which ones are attracted? So materials like dash and dash, which are attracted by magnets, are called what? Magnetic material. Like we say, things that can be attracted by magnets are what? We call them the magnetic materials. But things that cannot be attracted by magnets are non-magnetic materials. So for this one here, you will choose from the words iron, steel, magnetic, glass, rubber, non-magnetic stuff. Sorry. Okay. So next, let's look at page 31. The invisible push and pull. Okay, so whether two magnets can attract or repel one another. Okay, so page 31 and 32. Here we are told whether two magnets attract or repel each other. Remember, a magnet has got two poles. We have the north pole and the south pole. North pole, south pole. So what will happen when you put the north pole and the south pole? Can it be attracted? And when you put the south pole and the south pole, can it be attracted? Remember the law of magnetism says that like poles of magnets repel. Okay? Repel. And unlike poles attract. So this is repel, attract. Repel, attract. Now, unlike poles means that the ones that are not the same. Like poles mean that the ones that are the same. So, we are going to do an experiment about this. Okay? Number 2, page 32. So, what I need you to do, here we have a prediction. What you will do in your books, you will write, or this one, and then you circle your own prediction. What you think. Okay? Now, for the first test, you are going to do the experiment about attraction. But first of all, in the observation box here, you will write either magnets attract each other, if they attract each other, or if they repel each other. You will write it here. So, for the first one, we have A. Can you see? We have North Pole and North Pole. Sorry. So, these are our two North Pole. This is the red and North Pole. So, see. Can it be attracted? Can it be attracted? Can you see? No, it cannot be attracted. So, for your observation, you say repel. It means no attraction. So, magnets repel each other. You will write it here. Then, part B, let's see. We have a North Pole and a South Pole. Okay? This is South Pole and a North Pole. Let's see. But it's huge. Maybe it's going to fall down. See what happened? Okay, it attracts. Can you see? Yeah, so this one attract. So two sides that are not the same, we have south and north attract. Okay, so magnets attract each other or magnets repel each other. Next, we have south and north. It's the same. It will attract. Okay, and the last one we have south and south. Yeah, let's see. Can it attract? Can it attract? No, it just repel. Okay. What is our conclusion about all that? Law of magnetism. Remember I say that like poles repel and like poles attract. One more time. Like poles means the north and the north, they don't attract, so they repel. But unlike poles attract. Unlike poles attract. See what happened? It attracts. Okay? It means that two sides that are not the same, they attract one another. So here you will use the words repel and attract. So here we have use the words attract and repel. Like poles of magnets, like poles mean the same. Can they attract? No, they repel one another. But unlike poles, attract. Okay, so unlike poles of the magnet attract, like poles repel. Okay, for that one, we come to the end of the presentation, and I hope to see you next time. So make sure you do your homework. If you have any question, be sure to ask. So thank you and goodbye.